All right, so here we are at section 15.5, where we're going to evaluate trig functions on your calculator. So hopefully everybody has a nice scientific calculator. But before we can do that, we need to talk about what reference angles are. We've talked about reference triangles before, but now we need to figure out what a reference angle is and how to calculate it. So the first reference angle that we're going to talk about is one that's here in the second quadrant. And if I had an angle like this that's in the second quadrant, and I call that theta, woo, there we go, and I wanted to figure out what, I'll get a different color here, if I wanted to figure out what this angle was, because that's going to be the reference angle, obviously I'm going to have to go around an entire 180 degrees and then subtract theta, and that will give me the remaining piece. So the formula would be 180 minus theta. So let's try this out as an example. What if theta was 150 degrees? Following this rule, I would take 180, subtract 150, and I would get 30. So our reference angle is going to be 30. All right, so let's try it if it's in a different quadrant. What if it's down here in the third quadrant? So now, remember, this is our big angle right here going around. That's going to be theta. Draw that in. Ooh, my theta is horrible like that. Okay, and we are trying to figure out the reference angle. The reference angle, remember, is always made with the x-axis, never with the y. Okay, so the formula, you can imagine, we're going to have to go around here, our theta, and then we're going to subtract 180, and that gives us this remaining angle. So now this time we take 180 minus, theta minus 180. So here it was 180 minus theta, now it's theta minus 180. So what if our theta was 230 degrees? So now take 230 and subtract 180, and we get 50. All right, so I think you guys are getting the hang of this. Let's just do the last one. We're doing an angle in the fourth quadrant. Woo, that was really big. Okay, here's theta. That was terrible. Miss Quintapan's here laughing. So, okay, so there is the angle that we're looking for. So now think about this one. If I went an entire 360 degrees around and then I subtracted my theta, that's going to give me this little piece there. So 360 minus theta will be the formula for that one. Here's the example. What if theta was 340 degrees and we wanted to figure out what this little angle is? 360 minus 340 is 20. Okay, so either you intellectually understand how things are moving and related to the x-axis, and you can figure out on your own, or you need to memorize these three formulas. And of course, if it's in the first quadrant, the angle itself is the reference angle, so we don't need to worry about it. All right, now the fun part, calculator work. All right, so get out those calculators and play along. So what we have to do is to calculate what the cosine of 45 degrees and 10 minutes is. Now some of your calculators have special buttons with degrees and minutes, but some of them don't. And we have to pretend that we're on a desert island where we don't have a calculator that does that. So we need to learn the manual way to figure this out. So first of all, we need to figure out what fraction of a degree is 10 minutes. So if you recall from geometry, 10 minutes, you would figure out 10 divided by 60, and you get this decimal. So this is really cosine of 45.16667, which if you hit your calculator button, the cosine, and then this decimal, or maybe you type in the decimal and then hit cosine, you should get 0.705. So check it out, make sure you know how to work your calculator. Also, be sure that you're in degrees and not in radians. We'll deal with radians later, another way of measuring an angle. Okay, so that should be fairly straightforward. But now, what if we wanted to do the inverse of that? What if they gave us the decimal and we wanted to figure out theta? And notice that they've given us this interval that theta has to be between. That's going to be important in the future, you'll see. Okay, so in this case, when you need to figure out theta, you're going to do the inverse tangent, which looks like this on your calculator. There's a little -1 that looks like it's an exponent, but it's really not. Okay, so usually that would be above your tangent button. Maybe it's a second function key. I don't know, you'll have to find it on your calculator. So we're going to type in the decimal, hit the tangent inverse, or maybe vice versa, and you should get this decimal. So check it out, try it, see if it works. The thing is though, we want this to be in degrees and minutes just like this was in degrees and minutes. So how do we convert this back? Well, 11 is your degrees. We just have to figure out this decimal, what that is, as some minutes. So we're going to strip the 11 off, multiply the decimal by 60, and we get 40.05. Well, this is 40.05 minutes. And if we only want minutes, we're just going to round this, so that's 40 minutes. So 11 degrees and 40 minutes. Okay, so next. Remember how I said that there's this interval? Well, there's two places, if you recall, with all students take calculus, that tangent is going to be positive. Here and there. So here's our angle that's 11 degrees, 40 minutes. And down here, this little reference angle is 11 degrees and 40 minutes. What we need to do is we need to figure out what this whole angle going all the way around there is. So if our reference angle is 11 degrees and 40 minutes, how do you think we would figure out what that actual angle is? Well, if we take 180 and then add 11 degrees 40 minutes, we get 191 degrees 40 minutes. And there you have it. Okay, hopefully that wasn't too confusing, because now I'm going to make it even more difficult. Aren't you excited? Okay, so let's get rid of that. Let's get rid of that. Here we go. Now we have cosine of theta is negative 0.1439. Let's figure this one out. So just like before, we're going to do cosine inverse of negative 0.01439. We get this. Okay, so now we have to strip this off, multiply by 60, just like we did before. We get 15.37. This is the minutes. So let's round that down to 15. So we get 98 degrees, 15 minutes. So now let's think about, this is cosine that's negative. Which two quadrants are cosine negative in? So if you do all students take calculus, that would be the second and the third. So here are the two angles that we're dealing with. So the first one they've already given, we've already figured out, is 98 degrees, 15 minutes. The other one that we need to do, and this is kind of the weird thing that you have to think about, since we are going the interval between 0 and 360, we have to do this angle right there. Okay? However, if I were to make this angle down here, this is negative 98 degrees, 15 minutes. These are congruent. Okay? It's just the opposite direction. So let's think about how I could possibly get what this whole angle is if I know this angle is negative 98 degrees, 15 minutes. Well, if I take 360 going all the way around and then I subtract 98 degrees, 15 minutes, then I would get that remaining angle. So we get 261 degrees, 45 minutes. And if you're curious how this worked out, remember you have to convert 360 into 359 degrees, 60 minutes so that you can subtract your minutes. Okay, so your second answer is 261 degrees, 45 minutes. All right, so the rule of thumb here is that each time you are doing the inverse of one of your trig functions, you need to graph it out, look at the interval, look at the quadrants that they're either positive or negative in, and figure out your second answer. And that's going to be the hard part. All right, good luck, folks. I hope that was okay for you. And we are done. So